You know, when a patient gets a breast cancer diagnosis, an MRI is one of the most powerful tools a surgeon has. But here's the thing, its power is only as good as the person reading it. Today, we're diving into a new system that's designed to make that reading as close to perfect as it can possibly be. And that really gets us to the core question of this whole explainer. When the stakes are this high, literally life and death, how do you build a quality control system that ensures every single patient benefits from a scan that's read with the absolute highest accuracy? So why do an MRI before surgery in the first place? Well, it gives doctors this incredibly clear map of the cancer's extent. It's a fantastic tool for staging. But, and this is a big but, its routine use has actually been debated in the medical community for a long time. And that whole debate really comes down to one simple word: variation. Here's the challenge. You could have two brilliant radiologists look at the exact same complex scan, and they might see slightly different things. Now, this isn't a question of skill, it's about subtle interpretation. But those small variations can have huge consequences for a patient's surgery and their outcome, which has led a lot of people to question when we should even be using these scans. This brings us right to the heart of the problem that researchers wanted to solve: a major quality control gap. It turns out, for years, most of these specific preoperative MRI scans just weren't being formally audited. There was no performance review. Let's dig into why that was. Okay, so it all comes down to a classification called BI-RADS Category 6. In breast imaging, every scan gets sorted into a category, but Category 6 is special. It's reserved for scans of patients who already have a confirmed cancer diagnosis. It's basically the report saying, yep, we see the cancer we already knew was there. And here is the kicker. Because the main cancer was a known fact, these Category 6 exams were just automatically left out of the standard performance audits that check a radiologist's accuracy. It was a kind of logical loophole, really, and it created this massive blind spot. The result? Most of these critical preoperative MRIs were completely outside of any formal quality control. So to fix this, the official rulebook for breast imaging is introducing a brand new audit process, built from the ground up just for these scans. And it's all based on 4 key metrics. Let's break them down one by one. First up, you've got the abnormal interpretation rate, or AIR. This one's pretty straightforward. It just asks a simple question. Out of all these preoperative MRIs, what percentage get flagged for having something else suspicious, something that needs a second look beyond the cancer we already know about? It's all about how often a radiologist raises a flag. Next is PPV2. This one gets at the accuracy of those flags. It asks, okay, of all the things you said were suspicious and needed a closer look, what percentage of them actually turned out to be cancer? It's a measure of how good the radiologist hunches are. Third, we have PPV3, which is also known as the biopsy yield. This one is laser-focused. It's not about what was recommended, but what actually happened. It asks, when a biopsy was actually performed because of the MRI, how often did it come back as cancer? This is a direct measure of how effective those recommendations really are. And finally, the ACDR, or Additional Cancer Detection Rate. This one, you could argue, is the most important of all for patient care. It really quantifies the ultimate value of doing the scan in the first place. For every 1,000 of these MRIs we do, how many new, previously hidden cancers are we actually finding? So with these 4 new metrics on the table, the big question was, does this actually work in the real world? Is this audit even feasible? A team at the MD Anderson Cancer Center decided to put it to the test with a huge retrospective study. And just take a look at this flowchart to get a sense of the sheer amount of work involved. Over 2 years, they started with nearly 7,200 breast MRIs. They had to manually go through and filter out thousands of them just to get to the specific preoperative scans they needed for this new audit. So after all that sifting and sorting, they had their core dataset, 1,533 preoperative MRIs. This was the group that was about to go through this new 4-metric audit for the very first time. Now, out of all those scans, 464 of them, that's about 30%, showed at least one other suspicious finding, something that made the radiologist say, hey, we need to take a closer look at this, beyond the cancer they were already expecting to see. And this is the number that really hits home for patients. Following up on the suspicious findings led to the discovery of 139 additional, totally separate cancers that could have easily been missed until much, much later.
It's a perfect illustration of the life-saving power of these scans.
So let's make this a little more real. Here are some actual scans. The image on the left, that's a true positive, a suspicious spot that after a biopsy turned out to be another cancer. The one on the right, that's a false positive. It looked worrying, but thankfully it was benign. This new audit system is designed to track both of these outcomes to get a really full picture of performance.
So, what were the final numbers? Here are the big results from the ND Anderson study. An abnormal interpretation rate of about 30%, a biopsy yield, or PPV3, of 32.2%, and an additional cancer detection rate of almost 91 per 1,000 exams. The bottom line here is huge. For the first time ever, we have a benchmark. We have a target for what good actually looks like.
Okay, so what does this all mean for the future of cancer care? Well, the study proved one thing beyond a doubt. This detailed audit is absolutely possible. It can be done. But it also uncovered a pretty major challenge. 141 hours. Let that sink in. That's how long it took 7 radiologists working together to manually comb through the records, pull the data, and run the numbers for the study. That is a staggering amount of highly specialized work.
The study's conclusion was crystal clear. The new audit system works. It's a feasible and absolutely essential quality check that can help standardize patient care. And the fact that the performance numbers landed right where experts thought they would proves the whole concept is sound.
But that 141-hour figure, that's the real hurdle, isn't it? For this vital quality check to become a true standard of care that's available everywhere, not just at major cancer centers, the process has to be automated. Doing this by hand for every single scan just isn't going to scale.
And that leaves us with this final thought. The science is done. The metrics are defined. The process has been proven to work. The only thing standing between this powerful quality control tool and every patient who needs it is engineering. The question is no longer if we should do this, but how quickly can we build the automated tools to make this a reality for absolutely everyone.